In this recording, we're going to review units 5 and 6 from last year. So anything having to do with radicals as well as rational functions, so your fractions. First question we're going to look at is number 1. Ask us about a domain. Now you remember domain is the set of all x values. So what x values would not be allowed, basically? So certainly we could approach this by looking at a graph. That would be a nice approach, but we could also do it algebraically, thinking about, okay, any number under this square root can't be negative. So if the radicand can't be negative, what we'll do is set it greater than or equal to 0. So that's another way to mathematically say it can't be negative. It has to be 0 or greater. Now just do the math. There's our answer. We could confirm this graphically. Next question we're going to look at is number 7 on the next page. If you remember, we can transfer between rational exponents, that means exponents with a fraction, and radicals. So one thing we had said in this unit was power over root. Okay, when we turn it into a rational exponent, like this one is, the numerator is the power, the denominator is the root. The root would be written outside as the index of the radical. The power would be written inside as the exponent of the radical. So why don't you take a shot at parts 7, A, and B and play the recording when you're ready. Okay, so hopefully you tried this. There's a implied 2 as the index here, which we never write. Power 7 over root 2. In the second one, we're going to write this in radical form. So power is 4, root is 7. So 7's on the outside where the index of the radical is. 4 is on the inside as the exponent of n. You could also have written it this way. And you might see it sometimes like that. Next question. It's a radical equation to solve. Now, one thing to be really focused on in this type of equation, especially as approaching the Regents exam, is this is a class of equations that has extraneous solutions, meaning you might come up with a solution that is an apparent solution to the equation, but it does not check in the original equation. Okay? It's a solution to a manipulated form of that original equation. So the way to approach something like this is think about what you don't like about this equation. I think we could agree that we don't like this radical here. If it weren't there, it would be a lot easier. So try to undo that radical. But of course, we can't do that first. We have this 1 here that we need to undo first. So let's get the radical isolated. Okay, so we'll say we'll isolate the radical first, in which case it's still negative. But that's no problem, because when we square it, squaring a negative is going to produce a positive anyway. One of the biggest mistakes even good math students like you will make is not correctly squaring this binomial. You got to write it out twice, guys. I think you know this, but sometimes we forget. We get careless. We forget what we knew once upon a time. You got to write it out twice. You can distribute the x and then distribute the -1. Some people like a box. It can be done either way. Either way, you're going to get these terms. Well, I'll let you figure it out. I don't want to do the work for you. You figure that out. Get as far as you can with this problem, and then play the recording. Okay, so hopefully you worked something out here. This should be x squared minus 2x plus 1. And when you square a square root, you undo the square root. So we simply get the radicand. Hopefully you can take it from here. Why don't you do that and play the recording when you're ready. Okay, so hopefully you solved this. I'm going to solve this by factoring. You could also solve by adding 16 and square rooting. Okay, we have our two apparent roots here, But keep in mind, we may have what's called an extraneous solution. So I leave it to you to work out both checks. Play the recording when you're ready, please. Okay, so we see that this x equals 4 really does not check. So we call that extraneous. You can just put a line through it. If you like, you can write extraneous. And the only solution that we're going to circle is the x equals -4. Okay, the next question we're going to consider is number 10. For what values is this fraction undefined? Well, if you remember, way back when, you can't divide by 0, right? So we can't have anything in this denominator that's going to cause the denominator to equal 0. So what would cause this denominator to equal 0? We could certainly look in our table for values of x, put this in your y equals, or we could just simply factor this. Okay, those are the two factors that multiply to be this quadratic. Set them each equal to 0. Okay, so the two values that would make this undefined are +8 and -3. We have to be careful when we're answering this question. We make sure we answer it correctly. Sometimes it will say, what values are excluded from the domain, or what is the domain of this function, which would in that case be every x value except for those two particular values. All right, number 11. Simplify this division problem. Well, it turns out division is easier than addition and subtraction because we don't need any common denominator. What we really need to do is just factor everything. And while we're factoring it, let's go ahead and turn it into a multiplication by the reciprocal of the divisor. That means the second fraction, you're going to do the reciprocal, multiply it, the first fraction, the dividend, by the reciprocal of the divisor. So why don't you try to factor all four parts, all four quadratics. Play the recording when you're ready to proceed. Okay, so hopefully you did that. This first one's probably the toughest, but hey, they're all prime numbers, so it's not really that many factors to consider. Okay, it's got to be 2x and x. It's got to be 3 and 1, and you could just kind of play with it. They're all positives. Turns out the 3 is over here, and the 1 is here. Some of you like to use a box to factor it. That's great too. Denominator. That one is a tricky one because a lot of people look at that and say, oh, that's difference of two squares, x plus 2, x minus 2. It's not, right? That x is the greatest common factor. So please always look for that GCF first. We've talked about that. Take that GCF of x out first. Then you don't have any square on the x, so you don't have a difference of two squares. Okay. I'm going to factor this denominator, 16 minus x squared, up in the numerator because I'm multiplying by the reciprocal. So this is a difference of two squares. Got to be careful about the order here. In subtraction, the order does matter. So make sure you write the 4 first. 4 plus x, 4 minus x. Finally, we have a nice easy one here, looking for two numbers that multiply to 15, add up to 8. So you might find that your factoring is not fresh because we have not done it in our trig or our stat or probability units. Okay, well, just make a note of it. That's something you're going to want to get back. Because once you've done that, once you've done all the factoring, the division is pretty easy because you're just looking to divide out common factors, looking to divide out factors that divide to 1. So x plus 3 over x plus 3. Okay, a numerator and a denominator divide to 1. Okay, you might say, how can I divide across the multiplication sign? Well, remember, in multiplication, all the factors of the denominator get multiplied. And because I can change the order in multiplication according to the commutative law, I could really put that x plus 3 right underneath the other x plus 3 and divide them out. Okay, see anything else? There's not much here. 4 minus x, however, does have a factoring relationship with x minus 4, they don't divide to be a 1 like the x plus 3's did. They divide to be a negative 1. Where do you put the negative 1? I usually put it in the numerator. Could be put in the denominator, but it's probably more standard to put it in the numerator. So your final answer, negative 1, and then just write the remaining factors. No need to multiply them out. Why risk making a mistake, right? Okay, so there's our final form. Plus, in this form, I can easily see that there's no additional simplification that could take place. Number 12 is slightly more difficult because we do need a common denominator. It's an addition question. But perhaps the common denominator is smaller than simply this denominator times this denominator. And the only way I'll know that is by do some factoring. So why don't you take a moment to factor both denominators. See if you can find the lowest common denominator that we're going to need here. Okay, so hopefully you did that, and you factored this one out. As well as this one. Okay, they both share an x minus 1 factor. That's good news. So the way I like to think about it is, I'm looking over at this left fraction. I'm saying, what does it need that the fraction on the right side already has? And I see that this side has an x. So I'm trying to get both denominators to be equivalent. So I'm going to multiply here by a form of 1, right? X over x equals 1. So I can multiply by it. And I'm looking at this right fraction. It needs an x plus 4. Pardon my dog barking. So the denominator is going to equal what both denominators have, right? And the order doesn't really matter. So it's an x plus 4, and an x minus 1. All right. The numerator, and this is where, frankly, this is where students get a little messed up sometimes. So let's try to get it straight. The numerator, you have to do multiplication before addition. So multiply x times x minus 2. So x squared minus 2x. Multiply 5 times the quantity x plus 4. Okay, again, I'll say that one more time because I've seen a lot of students struggle with that. They get to this point and then kind of lose their minds. They don't really know where to go. Multiplication has to precede addition. So we multiplied. Now we can add any like terms, those middle terms. It's said to express this in simplest form. If it were possible to factor the numerator and divide any factors with the denominator, I would do that. I don't see a way to factor that numerator, because I don't see any factors of 20. They're going to add up to 3. So that's going to be simplest form right there. Next question we're going to look at is number 14. And so since we just worked on a addition problem, this is a subtraction, which is very similar. Let's have you work this one out and play the recording when you want some help. Okay, so hopefully you worked this one out. The first thing I always like to do, I have my students change any subtraction when it pertains to subtracting fractions to addition of opposites. Okay, so I'm going to make this plus negative 5. I'm going to change the numerator to be a negative, its opposite. Keep the denominator the same. At this point, just need to get a common denominator. I can't get a common denominator by adding 7 to the numerator and denominator. I can't do that. I can multiply by a form of 1. So multiply this side by what it needs. Multiply this side by what it needs. And we did this in Algebra 1 and in Algebra 2. And hopefully now in pre-calc it's finally setting in like, I finally get it. Because this is hard, but you can do it, right? So now we just do what we said we're going to do before. Keep the denominator. It's common, so when we combine fractions, we keep the denominator. We combine terms in the numerator, but of course we have to do multiplying before we can add or subtract. distribute that negative 5. That's why I changed this to be a negative 5, addition of opposites. Because I've seen so many times students not do it that way, and they don't get the sign of the final term correct. This needs to be a negative 35, and too often students won't get it right if they do not change it to be addition of opposites. We're looking at number 15. This is a solve for x type of situation. First thing I like to do in these fractional equations is state the values of x that would make the fraction undefined. So why don't you go through all those denominators and tell me any numbers that x cannot be that are going to cause us to divide by 0. Okay, so hopefully you recognized if I have an x equals 0, that's a problem, right? Can't divide by 0. And then again for this fraction, what would make this denominator equal 0? Well, a 2, right? And then it's harder to see in here, so let's factor. Let's pull out the GCF and call it x minus 2. And then I guess we can say, well, those are the same factors as before. So I have those same restrictions on the domain of this equation. So we want to get rid of the division. This is a rational equation. It has division in it. And the first thing we want to do is turn it into a comparable equation that has no division. So I'm going to multiply by something that will divide out all these denominators. So I'm going to multiply all terms by the LCD. Okay, and that LCD is going to consist of an x and an x minus 2. And then, well, we already have an x and an x minus 2, so I guess that's really all I need is an x and an x minus 2. So when I say multiply all the terms, what I do is I write it right next to all the terms. Okay, so now we can see what divides out. So in this first term, x's divide out. The next term, x minus 2's divide out. In the final term, the entire LCD divides out. So the point of that is, look at all my denominators. They've all divided to 1. So I have no more fractions, and I can simply write the equation that results by distributing and simplifying. So I'm distributing the 5 to the x minus 2. I'm distributing the x to the x plus 1. And there's no distributing on the right side. Okay. So it's not easy from here, but at least we got it to be a quadratic. Why don't you take it from there, see what you can find, and keep in mind we have potentially extraneous solutions in this type of equation. Okay, so let's work this out. Getting all terms onto the left side. This looks factorable. I could also solve by my quadratic equation. Okay, it looks pretty good, right? I got 2 solutions. But pause. This is the type of equation that potentially has extraneous roots. Up here we identified our first step. We identified 0 and 2. And that was the whole point of doing it, to get us thinking about the fact that there might be extraneous roots. That right away is extraneous. If you're saying, what if on my regions I forget the word extraneous? Don't freak out. Just put a line through it and say no or omit or something. This one looks like a solution. Before I circle it though, I'm going to come over here and do a check. Alright, in the key for this, I work through all the steps, getting common denominators and solving, working it out. But you can also just pop it into your calculator. We really just want to know, is that left side equivalent to that right side? And it turns out, when you do all the work, it works out to be negative 3 over 63, or I guess that would be negative 1 over 21 if you popped it in your calculator, is equal to negative 3 over 63. Which checks, therefore, I'm going to go ahead and now circle my root. Okay. So, got this final one. This one's got some curveballs, right? If you think you know how to do it, why don't you go ahead and take a shot at it. Okay. So this one, why don't I just intervene a little bit as it relates to this? We said we would potentially deal with this a little bit. So I'm going to turn this into addition of opposites, plus negative x. I also, when I'm looking at the factorization of this one, this is going to be an x plus 1, x minus 1. Okay, so the first thing I'm going to identify are my values of x that would cause this equation to be undefined. So why don't you write down the numbers you think it is? Okay, so it's negative 1 here and a positive 1 here. And then, again, we repeat those two numbers. So x cannot equal either one of those. So if you get those in your answer, you know you got to exclude them. So I'm going to do a little trick here that if you're spaced out, really dial into this. The 1 minus x over x minus 1, these are called opposite binomials. They divide to be equal to negative 1. Okay? So I'm going to factor out a negative 1 here and write this as x minus 1. Okay? That's good news because now I really just have a negative over a negative, which I can write as a positive. Okay, so that middle fraction, let me just get my left fraction written down. My middle fraction, I have a negative in the numerator and in the denominator. Let's just say, hey, those divide out to 1. And that's going to be pretty tight because we have two factors in the denominator and 2 factors over here in the denominator. Therefore, that's going to lead us to our LCD. If this is still hard for you, relax, be patient with yourself. It has always been hard. It is challenging. I think it's one of the most challenging things we do. So just be patient. You're going to maybe need some reps with this before you feel comfortable. All right, so think about what we're going to multiply by. We don't like these fractions. We set up above, we're going to multiply by the LCD by all terms. So I got to have an x plus 1, an x minus 1, and that's it, because we have an x plus 1 and an x minus 1 over there. Those divide, those divide, those divide. See if you can take it from there and solve it out. Okay. Hopefully you did this work already. I'm distributing the 2. I'm distributing the x. I have a quadratic. I think to myself, is it linear? If it's linear, I solve it a certain way. If it's quadratic, I want to get a 0 on one side. I want to combine all my like terms. You should expect these to factor. If for some reason they don't factor, go back and check your work. It's usually a mistake. Okay, so I have my 2 roots, but up above we had stated that x could not equal negative 1 or 1, so that's a contradiction here. It's extraneous. Again, before you circle it, go ahead and check that x really does equal negative 4. Again, on the homework key that I posted on Schoology, I've worked out all the steps. Turns out, if you could put that in your calculator, the left side and the right side, we really just want to know are the 2 sides equal. We know we can do this math if we need to. Really just want to confirm that it works. It does. Last problem we're going to look at is a simplification of a radical. This is on your eMath Unit 8 review quiz. Now, problem number 2. Okay, so it's a cube root, which is challenging. You're not as familiar with your cube roots as your square roots. So let's list out some perfect cubes over in the margin. 1 times 1 times 1, 2 times 2 times 2, 3 times 3 times 3, etc. I think that's as far as we need to go. I'm looking for one of these, the largest one, that will go into 250. Okay, so that's obviously going to be 125. And it has a other factor of 2. So the next thing I'm going to look at is x to the 8th. This is where you have to be heads up because 8 is a perfect cube, but x to the 8 is not. Perfect cubes for exponents would be exponents that are divisible by 3. X cubed, x to the 6th, x to the 9th, x to the 12th. So the best I can do here is x to the 6th. It's the largest perfect cube that goes into x to the 8th. X to the 6th is a perfect cube, and it has a remaining factor of x squared. Keep in mind, I add the exponents when I multiply. So perfect cube, I like to circle them. Those are the ones I know I'm going to be able to simplify. So cube root of 125, well, that was 1, 2, 3, 4, that's 5. Cube root of x to the 6th, well, I divide, remember we did power over root before, so that's another way to write x to the 6th over 3. Well, that's obviously a 2, right? And then the remaining factors stay under the cube root. Looks like we did it. Looks like choice 3. Thanks for watching.